Hello everyone, my name is Smith Devanya and my topic is RST instruction in 8085. Interrupt using RST instruction. The 8085 provides 8 RST restart instruction. The restart instruction takes N0 to 7 as operand, and when it executes, it saves the address of next instruction on stack and jumps to location that multiplied by N. The binary code of the RST-N instruction is given below. In the given diagram, the bits D5, D4 and D3 are replaced by the 3-bit binary value of n of the n 0 to 7. The value of n is multiplied by the 0 to get the memory location, where control is transferred. Table below lists the opcode and jump location for all the 8 restart instructions. This is the table where total 8 instructions and binary code, opcode and jump location is shown. Software interrupt using RST. Observe that the distance between two jump locations for subsequent RST instruction is only 8 bytes. The 8 bytes are not sufficient for writing an ISR for any purpose. To solve this problem, generally the ISR is written at some other location in memory and the jump instruction to that location. Where actually service routine is written is provided at the RST jump location. Figure below illustrates the concept. As shown in the figure, the mainline program is written starting from location 2000H and contain RST instruction. The jump location for RST instruction 0018H, which stores the jump instruction 4000H to transfer control the actual service routine. During the execution of mainline program, when RST instruction executes, it transfers control to location 0018H. The execution JMP 4000H instruction at that location further transfer to control at the location 4000H. The service routine at location 4000H starts executing and provides the service. At the end of service routine, execution of RET instruction transfer control to mainline program at the instruction after RST. Remember that the RST stores the address of next instruction on stack and then jumps to its jump location. This is how the software interrupt using restart instruction work in 8085. Hardware interrupt using RST. The RST instruction is single byte instruction, and when executed, it saves the address of next instruction onto the stack and jumps to its jump location. Figure below shows how the hardware interrupt is implemented using external hardware and the RST instruction. This is the figure shown below. Assume that the RST3 instruction in a mainline program assume that during the execution of mainline program the device sends a high signal on the INTR pin. We know that the 8085 checks the hardware interrupt at the end of each instruction. The 8085 finds the valid signal on the INTR pin. The next cycle it generates is the interrupt acknowledgement cycle, which consists of 3 machine cycles as follows. During M1, the signal goes low, which enables the buffer so that code for the RST3 is placed on the data bus, which is decoded as RST3 instruction. During M2, the lower byte of program counter is saved on the stack. During M3, the higher byte of program counter is saved on the stack. Whenever hardware interrupts occur, the processor stops current program, disables the interrupt, and then jumps to the ISR. This is done to ensure that the execution of ISR is not interrupted by the other interrupts. The 8085 automatically does not enable the interrupts again. Hence, it is responsibility of the user to put the EI instruction to enable the hardware interrupts so that one interrupt program is resumed. The system can accept the valid interrupts.